All right, so now we got function purity out of the way. And again, that's just the beginning. Honestly, it goes much deeper than this, but you have the core concepts, and you have, more importantly than that, the idea of what we're trying to do, right? We're trying to reason about our programs, which is a part that's pure and a part that's impure. And, we're not so concerned about the names at this point, but simply what that means is, hey, here's a part that's predictable, and here's a part where we're going to be doing other stuff, right? That's not predictable. And what we want to do is we want to separate those parts of the program. So if we have a bug, we know where those bugs are, right? So we're not looking all over the place. And again, as your applications get bigger, that's really when it starts paying dividends, because believe me, if you've ever tried to track down a bug for like 1 day, 2 days, it's just not fun, right? And that's not what you want your team doing, right? You want your team creating applications and dealing with users and making just, that's what we come to write applications, to make better user experiences. And that's why, using some of these functional programming concepts, maybe you don't have to get your whole application to be, in a functional programming style. But now you can start putting parts of your application and understanding why those parts are that way, and start transferring your code over bit by bit. Okay, so now let's get into arguments. And again, what does it all mean? Now, if you've taken a calculus class or an algebra class, this should make perfect sense to you. But even if you haven't, it's not that complicated. Okay, the arguments are the variables that we pass into the functions. Okay, on one end they're called parameters. On the other end they're called arguments. So when they are in the function description, right, those are the arguments. When they are when we're calling them, so we're actually calling the function, those are the parameters of the function, or vice versa. It's one or the other, but that's pretty much the idea. Okay, one is the arguments that the function takes in. The other one is when the function is actually being called, the variables that we're passing into it. Okay, so that's those are the parameters and those are the arguments. Now, the thing about functional programming that's very interesting, and this kind of something I've been alluding to throughout the course, is we want to think about pieces, right? Our program is composed of these Lego pieces that we're going to eventually combine to create our application. Okay, and that's where arguments and parameters come in. Now, the reason being is, let's say you have a Lego piece, right? And one of the holes is bigger than the other. Then those Lego pieces don't compose, right? Automatically, you're dealing with something that doesn't fit together, okay? And that's what we're going to be calling throughout this portion of the class, the shape of the function, okay? Or the shape of your of your program, okay? Or however you want to word it, but that's kind of what we're going to be talking about, okay? And we're going to be talking about three main shapes. There are three main shapes that we want to focus our attention on, and three main ways that we want to organize our application and our functions when we're writing them. The first one's called unary. So a unary function is a function that takes in one argument, okay? One argument and returns one argument, right? So this unary function is called increment, and what it does is it takes in an x, it passes this through, it calls a function called sum, and then it returns the, again, this is not a pure function. As we see, we're calling something outside of ourselves, but let's just go with it for the purpose of the example. Let's just imagine that sum is a function that just adds, x plus whatever the second parameter is, and then we're returning that, right? So the shape is one input, one output. That's the shape of a unary function, okay? The shape of a binary function is 2 in, 1 out. Okay, so two parameters, two arguments in the function argument, so x and y, and then we're returning the summation of that x and that y. So let's say it's 3 and 5. What we're returning is the number 8. So 2 in, 1 out, right? 3, 5 in, out 8. Okay, so and given the same input, right, we get the same output. So it's predictable, and this is a pure function, right? So we're using everything within the scope of our function, and here we can see that the sum function was what we were saying. So in 1, and then sum returns 1. Over here, the binary function takes in 2, returns 1. And then also, that's if we're dealing with literals. So literals are strings or integers or floats. Those are literals. But we can also pass into the function another function. Okay, and you've probably done this in the past, callbacks. Whenever you pass a callback function to a function, means, hey, pass me something that we're going to call later on. Okay, so maybe you want to set up, right? And this is why the shape of the function is so important. And functional programmers actually care a lot about the way they provide the arguments to the function. So if we come from an object-oriented programming style, and I'm going to switch over to Sketchbook so we can get a better idea of what I'm talking about here. Let's say we have an object, okay? Let's say we have this object called car, okay? Car, and then the object, okay, has this argument called total wheels, okay? And again, depending on the car you pass into it, the total wheels will be different. But over here, as you can tell, this car model is binded to so this property is part of the car attribute. Okay, so these two things don't, they're not separate. So that, to get this value out of the car, we have to have a car. There isn't like a total wheels function that's completely independent of a car, and we can call it for a bicycle, let's say, or a truck, or anything else that might have a total wheels thing. So now, this function, if we have a bicycle, a bike, now we have to, again, we have to duplicate our code. So this one will also have a total wheels, right? Because it's part of the model, right? As you can tell, in functional programming, what we're going to do is we're going to call a function. We're going to create, first and foremost, a function called total wheels that takes in two things, okay? It takes in a model, and it takes in, and that's all. That's all it does. So it just takes in a model, okay? And from this model, okay, it can take any model, right? And then what it'll give us is the number, okay? The total wheels number. That's what it'll return to us. So given this function over here, we can tell the difference between this function, okay, and this object-oriented style is that this, okay, the total wheels is tied to the model in this example. Over here, we have a completely separate function that we can call with any model, and it'll spit out the total wheels on it. Okay, and that's a big, like I said, it's a big win when we're creating big applications. The fact that everything doesn't, we don't have to tie our logic to either our mutation or our transportation of data. Okay, we can deal with them individually and create functions that deal with it without being tied to some arbitrary model that ties it to that, and without it we can't use that function, or we have to duplicate it somewhere else. Okay, so a unary function that returns a function and then calls it later on with the second argument passed. So if we call unary, and this is very similar to what we did over here, right? So to add another, we return the function that we later call with two extra arguments. Okay, so over here we're just kind of representing that. So we don't just have to pass a 3 or a 5. We can actually pass another function in. Okay, a function that we'll call later on. So for example, and then over here we can simulate that the example I was trying to give you earlier, which is you don't just have to pass in literals. Okay, over here we're passing in a function called z. Okay, z, what we're gonna call it's the function add numbers, but now it has we've used it as a function. So z over here is add numbers. This is the first thing we pass, but we're not using it, so that's gonna return us. Okay, at the beginning, all we're doing is we're returning a different function that takes in two arguments. Okay, and then z is gonna call whatever was passed in as the first argument, which is a function, in this case, the add numbers function, with those two arguments, okay? So you can not just pass, you don't have to just pass literals like a string or an integer or a float. You can actually pass functions around, and that's part of what we mean with functions are first-class citizens in functional programming. You can actually pass functions that return functions, okay? And then keep doing that over and over again until you actually build your application. So this is one of the ways that we're going to use to build our complete application. And then this is how you can see that, hey, what if I don't just have a string, and what if I don't just have a number? Like, what if I actually want to pass some computation that, okay, I don't want to do it now, so I want to set it up now. So over here, we set up the function add2, but, we could have passed this anywhere, right? So this function add2 now, okay, we can pass it around to a different file and use it in a different file and call it with two other numbers, and it'll remember the add numbers function that we passed in this file. So what that does, that's called closure. Closure is when a variable, okay, when a function remembers a variable outside of its scope, okay, that it was used in. And that's what, we'll get into closure later, but closure is one of the ways that we can build our application, as you can tell, doesn't have to compute anything at this point. All we're returning over here, once we call another, all another asks for us is to pass in a function, okay? You pass me a function and to add another, and then it'll return you just another function that takes in another 2 arguments, okay? And then we can see that here. And then later on, when we call that return function, okay, with those 2 arguments, we will get the final value out, and the final value being 9. But we can, as you can see here, we passed in the add 2, 4, and 5 into console log, which is also another function, and we saw it at the beginning. Okay, so here we're adding the actual value, the actual total, right? The return value of what the add 2 number is, which is a function we set up earlier, into the console log function, and seeing the output in the console. So those are 2 very powerful ideas of functional programming that, besides the fact that you can pass in a string or an integer or a float, you can start passing in functions. And then this way, we can start building more and more complex Lego pieces that eventually add up to a full application, okay? So that's what the arguments are so important. And the way we pass them in, okay, usually in an object-oriented programming, if we go back over here, okay, in object-oriented programming, let's say you have an array, okay? Let's say you have just a collection of 1, 2, 3, 4, okay? And then you want to call a function in that array, let's say a for each. So you want to iterate over this, okay? And for each time you iterate, okay, you're gonna call x, and what you want to do is you want to do x plus 1, okay, and then that's gonna be your return, okay? So what we're doing here is the same thing in an object-oriented way, which we have a for each function that's attached to this array primitive that we have in JavaScript. But essentially, we have to have the data available, right, to operate on it, right, to call anything on it. But in functional programming, okay, we flip that, okay? We don't have to have, okay, the data available to us at the beginning. We can imagine, okay, and we can set up a function that once we have the data available, this is what we want to do with it, okay? And that's what we're doing over here, okay? So at this point, okay, I can add 2, okay? I can create this new function called add 2 without actually having the 4 and the 5 with me, okay? So without having this data around, and this data might be data that then the client has, right? So let's say we're doing some operation on the client, and the client actually will pass in the data, but at the point that we want to create, or we want to create our API, we won't know what the data will be. So we can't, we can't do any operations on the data. But what we can do is we can create these functions that do the setup, okay, and that they're pure. And because they're pure, they're provable. So we can say, hey, as long as, we created this little function called add 2, and what it does is it adds 2 numbers together, okay? But we don't know what numbers you're gonna use. You can choose your numbers, okay? But this function, when you pass it 2 numbers, it will sum them up for you and then give you the total. But that function was created ahead of the data, right? So beforehand, like we didn't need to have the data to create the function. And that's a super powerful concept. And that's one thing that we do all the time in functional programming, right? When it's not just the shape of our arguments that matter, okay? It's also the position of the arguments within the function parameters, okay? It's the order that we pass the arguments in that also matter, because most of the time, what you want to do is we want to go from the general to the specific. So the general, okay, in this case, okay, is we know we have a function that's going to add 2 numbers together, right, 2 integers. But we don't know what 2 integers, right? So what we've done is we created a general function, okay? It's very general. We don't have to pass it anything. We don't even, it just takes 2 inputs. And whatever those 2 inputs are, then it adds them up for you. But at that point, it's just, it's a function that doesn't know anything else other than, hey, you passed me 2 numbers, and I'm going to add them up for you, and then I'm going to return them, okay? Now, once we had that function created, okay, so to add another, we created this unary function that's going to return us that function that we can then pass it to these 2 variables, and then it's going to call it in another context. So we can pass this, okay, this add 2 function to the client, okay, or create an API that the client calls themselves with 2 numbers, and then they get the result, 9, in their console. And this way, we have understood, we have actually gone over a few concepts over here. We have gone over closure, we have gone over function composition, okay? We have gone over the argument shape, and we also have gone over the order in which the arguments come in. And all those things are gonna matter when we're creating our application in the functional programming style. Okay, so remember that. Okay, so the shape of the arguments, okay, matter because the composition matters. So if you want one to go into the other, so, and we'll see examples of that in a little bit, then the shape matters, right? Because if one function, okay, is expecting two parameters, okay, and we want to then compose these two functions together, then the function that, for us to compose two functions, if one accepts one parameter and the other one's returning two parameters, then they're not going to fit together, right? They don't go together. It's kind of like an outlet in your house, or if you want, every single electrical device has a power conduit, right? And the power conduit has an outlet, but the outlets, okay, and depending on the country you are, they've been standardized, right? So as long as the manufacturer creates a power cord that fits an outlet, then what the electricians have said is, hey, you provide an outlet and something that to plug it into, and then it will provide power to that device, right? And then pretty much you can just look around your house. This is how everything runs, and it's the same thing that we're going on over here, and that's why it's so important the shape of the function. You can think of it like an outlet, right? If you want the outlet to work, then you have to provide it something that fits in that outlet, right? You can't just use any shape, right? It's not just anything will fit into that. It's a very specific shape that fits into the outlet. But then look around how many applications have that same shape, right? Pretty much everything that you have connected to the electricity has that shape. So that's the exact same thing that we want to think about when we're thinking about the shape of our functions. We want the shape of our functions in order for them to be able to be composable, in order for one input to become the one output to become the input of another function. Then we need their shapes to fit together. Also, we can pass functions into functions that will be called later, right? So they will remember what initial arguments that were passed in. We can then close over them, right? So we have closed over this variable fn that we pass into the first function, and then once we actually pass those 2, 4, and 5, okay, it remembers this function that we passed in. And again, this could be happening, on the server. The server can send this function to the client, and they could be happening in two completely different environments, two completely different computers, okay, even, and it'll still work, okay? And that's really powerful, okay? This is how we can keep open socket connections. This is how we can keep, this is pretty much how real-time applications also work, okay? So again, very powerful concepts over here that I want to that we want to understand as part of our functional programming toolkit, okay? So again, that's kind of the idea. So remember, the order matters. You can pass functions into other functions. You can return functions from functions, and then you can remember those functions in a closure so that you can use them later on, okay? And remember, since we won't be, you want to go from the general to the specific, reason being is you don't always know, right? The data usually is very specific. The data will usually be the most specific thing. So your arguments, okay, when you're creating your function signature, you want to make sure that your arguments are in the order that you expect them to come in. So if you expect the data to come in last, then that's where you're going to make your last argument. But if you have other things, right, as you're composing these functions, you're going to have other things available to you that you're like, well, I can set this up right now. I don't need to have the data to set up the sum function. All I need, or to set up the add2 function, all I need to set up the add2 function is to pass it a sum function, and later someone else will worry about passing in some data to that add2. As long as I give them that function, then they can just pass in 2 other arguments and it'll work, right? But you can do the whole setup, independently of the calling of the function, okay? And that's what we want to focus in, right? We want to focus on the fact that the function call and the function setup can happen independently, okay? And part of the way we do this is by, again, function composition, right? You want to make sure that the order of your arguments is in the order that you expect them to come in. And, contrary to object-oriented programming, where usually you have the data available right away, in functional programming, usually the data is the last thing we have available, right? So because it's the most specific thing. And like I said, since we don't want our functions to be tied to anything that it doesn't need to be, right? We want our functions to be pure in order to be interoperable and in order for them to be portable into other libraries or languages or frameworks, right? That's why we can't have them being tied to a car model or anything like that. We want to be able to pass the model later, okay? But we don't want to ahead of time define what that model is going to be. We want that if let's say we're working on a bigger team or we're creating an API and we want to give that control over to the user of our function, then we say, hey, you provide any model, okay? And then we're going to create this function called count wheels. And as long as your model has wheels, then we'll tell you how many wheels it has, right? And that's kind of the way we want to start wiring our brain to change over from object-oriented programming into functional style of programming, okay? So the data is the specific thing, and the more general thing are the functions. So the functions, we can compose them and then wait for the data to be applied later on, okay? And so that's why the arguments matter and all that. And again, what I'm going over here, these are functions that we're going to be going over in more detail when we're creating our application. But they kind of show what we've been discussing so far, right? So over here we have a function called reverse args, and reverse reverse args takes in a function, okay, and it returns another function. And that function all does is, is that function in reverse. You pass in the arguments, and then eventually someone's going to call that function that we initially passed in with those arguments reversed, right? And again, part of the reason why you might want a reverse args function is, again, if you're coming from a object-oriented programming style of coding to this style of coding, then if the data was the first thing you were expecting and now is the last thing you're getting, then you might need to reverse the argument order. And these are utilities that you can create yourselves, but usually they will be provided for you in a library. Okay, so you don't need to actually go ahead and implement this yourself, but I did want to show, and it's more specifically Kyle, when he taught this, this is, the way he was teaching us was that, sometimes you want to be able to create new function signatures, and you want to know that, hey, you have now the capabilities to do this yourself. So whether it's provided to you by an API or you actually go ahead and create it yourselves, you now have the power and you now have the understanding of how these things are done. And but again, we'll be using libraries for most of this during our class. Okay, but anyways, so very important thing. So over here again, same thing, XYZ. So we're just going over the spread operator and the unspread operator, which is something we covered earlier. It's just a way to pass around function parameters and arguments into our function. Okay, and this is more specific to JavaScript. So when you pass it in as the arguments to the function, it'll provide them in a one by one, way, where you can pass an array and then it'll split that array into actual function arguments, and then when you use it to make the function call, it will gather all those arguments instead of spreading them. Okay, so that's the difference between the spread and the gather operator. It depends where you're using. Now let's go over point free. And point free, we've actually already seen what point free is. So let's actually +5. Okay, so what I'm going to be doing right now, I'm going to be providing just the x. So what you see over here is that this function, the shape of the function is, at first we're going to have a shape that takes in one argument. Okay, then the next function takes in another argument. Okay. Okay, so both of these function arguments, both of these function signatures, they both, if you can tell, they both take in one argument. Okay, and that's the shape. Now, what we can do is when we get back add numbers, okay, we can just say, hey, we don't even need to pass add numbers that x that is expecting. Okay, we don't even need to pass it over here. We can just pass the function. Okay, as you can tell, this function takes in one argument. Well, we didn't pass it. We didn't pass it here. Okay, we could have passed into 4 because that's what it takes, right? The add another, and then we passed, the function add numbers, and it takes one argument. But we didn't pass it any arguments, and it's not just because we provided it up there as a default. Okay, so we can take the default out and run this program. Actually. So yeah, so we won't set the default, but we actually still want to take in one argument, but we don't have to set it. okay? And that's the important thing, right? So we didn't set any default, okay? And all we said is, hey, we take in an x, but it could be any x, okay? And because these two, okay, so because this function, and when we're calling the function, okay, they have the same shape. So this is a unary, they're both unary. We can actually just pass in this function, and once we pass the number 4, okay, it'll get passed around until it reaches the final function call. And because they have the same shape, this function will call this function, which then will call this function with the same argument being passed around. And that's what we mean by point free, okay? And point free is another reason why, okay, we focus so much on the shape when it comes to function programming, because again, when we're composing these programs, okay, we want the shapes to fit together. And if the shapes do fit together, okay, it allows us to create programs that in this style called point free. And again, for me at the beginning, point free was very, very, I was like, how is this thing not accepting any arguments when it's actually saying that to use that function, we need to pass that argument. The thing is, over here, we're not actually calling that function, right? We're calling a function, it's going to become this function eventually once we call it, because we're returning a function over here. So we want to, focus on function calls, okay, not function definitions. Over here, all we're doing is the setup, right? So then this fn, okay, will eventually be called, but we don't need to call it right now. All we need to do is pass it in as a parameter, right? Pass it in as an argument, and that's all you need right now. And then I'll return to you a function. You can name it whatever you want. In this case, we named it add2. Now we can call it add1 because we're only adding 1. Actually, we're adding 5 because that's, so we call this add5. Okay, and now if we pass 4 to add 5, we should get 9, right? If we pass 9 to add 5, we should get 14. And there you go, right? So this function in a point-free style, okay, allows us to, because they have the same shapes, right? One argument, one parameter, one argument. Then over here, once we call this other function add5, and we actually do call it, okay, with any number, it's going to add 5 to whatever number we pass in, right? So that's the reason why the shape of functions are so important. And we can go in. This goes into more detail, but just remember this name, and I'll pass around with the class some resources. This is called equation of reasoning, right? Because we know that we only take in one input, then the actual the interpreter of the JavaScript interpreter, but in many functional programming languages, it does this as well. Then we can make some performance optimizations that again, that's why we don't have to pass in the argument at the beginning, as long as the functions have the same shape, okay? Now again, you don't need to understand equation of reasoning to get the benefits of it. But again, I've kind of given you an overview because you're going to be seeing it more and more as you start doing functional programming, and then it'll just become so natural to you that that you'll be able to use it everywhere. But again, remember that your programs, the most important thing about writing programs, and especially when we're going into functional programming, is you want to be able to understand your programs. That's what we are going through the trouble of breaking our programs up into smaller functions, right? Smaller parts that we can compose them. Smaller parts that are easier to understand. Smaller parts that are easier to reason about, okay? What we want programs that are maintainable for the future without requiring so many resources. Because once we, if we need a whole team just to debug programs, okay, and every time we're trying to onboard a new member into our team, we have to just, explain to them 80 things they have to understand to understand our code base. That becomes very, very hard to maintain, right? From a team perspective, from a code base perspective, and the technical debt kind of builds up really quickly, okay? So, sooner rather than later, what you'll find yourselves is you're going to be spending more time debugging and, programs than it is writing applications. And I think what we all want to get to is just writing applications, because that's the fun of our job, okay? We really don't want to be in the job of refactoring and debugging, because that's no fun. So anyways, and we can see examples over here. So we have the isOdd function, which again is just kind of like a filter function. It's a Boolean. Okay, so this is a different shape than a unary, binary, or n-ary. So the shape of this, it's one input and then one output, but the output is actually a true and a false. Okay, and in functional programming, you will see that we will deal with a lot of that true false binary functions in order to get some type of value, or in order for us to compose functions together and we want to do some comparison, we can use this this type of binary function that returns the true or false. Okay. So we can also define functions in terms of function and write them in point free style. So over here you see that the is even and the is odd, they have the same shape, right? So that they both take in one argument, and then we can define. We just define is odd, but because is odd is just the reverse of is even, then when we are creating the is even function, we just have to say, hey, it's just going to be exactly like it's even, but except it's going to be the opposite. So if it returns false, then whatever it's not odd, then it must be even, right? Because that's just the way odd and even works, right? Something is either odd or it's even. So those are, and you see that we didn't have to actually do the calculation. It was a more expressive way to write this function. We didn't actually have to say v divided by 2 equals 0, right? So we didn't actually have to know the how. All we said is, hey, we already have an is odd function. Just whatever is not odd, it must be even. So just, if it's not odd, then it's even. Just return the opposite. And we expressed it in terms of another function. And that's another thing that we can do with functional programming. And this is, again, an insight into something that we will see when we're writing applications, is that now these functions are being composed in an expressive manner. And they almost read like you would a text, right? They almost read like English, right? So what is odd? Is odd is the opposite of is even. That's all it is. And that's all we have to know, right? We didn't have to know the actual implementation details of the is odd functionality. As know that we have an is odd function and we know that it's provable, then we're just saying, hey, you know what? It's just whatever, like the opposite of it. And that will give us the is even function. And then, this function literally is one line of code, right? Plus, of course, the function definition. But the computation is just one line of code. And what is it? Well, it's the reverse of is odd. And again, then our programs becomes a lot more expressive and easier to understand. And you will see that the programs actually not just are easy to understand, they almost start reading like if it was English or a language that you're reading. And you can almost read your program out. Okay, and that's very cool once you see it actually play out. This is also another way to express the same function. So over here, we're writing the not function, okay, and it's a utility function. And what we're gonna say is, instead of having this bang, so this bang over here is, JavaScript provided us that function, and what we're gonna do is we're gonna pass the other function is odd to it. And this is just syntactic sugar on the JavaScript engine that the language has. But if the language does not have this this little bang operator, then we just create it ourselves, right? And that's the power of function programming. We're just going to create a function called not, okay? And it returns to us a function, right? So something that we can pass something else to. And what we're going to do is we're going to pass this function called negated, and you can pass it any number of arguments. And then we're going to say, hey, negated is the opposite. Call it the first function, and then whatever it returns, give me the opposite of that. So now we have is odd, just like I was before. But now to express the is even function, we didn't have to write the whole function like we did here. Function is odd, right? We didn't have to go through the whole ceremony of setting up the function, all that. All we're saying, hey, variable is even equals not is odd. Okay? And then that's how you can see that the program becomes very expressive. Okay, it reads, it's declarative, right? So it's reading almost like if it was English. And this is point free, because is odd, okay, takes in one argument, and not takes in one argument, and is even takes in one argument. Then all we have to do is we're over here in the first section, we're just setting it up. We're saying, hey, to the not function, pass the is odd function. Don't call it yet, okay? We don't need to call it yet, but we're just setting it up, okay? And then we want to then say, hey, that expression, we want to store it in a variable called is even, okay? But because we know that the return value is a function, we know that that variable, once it's called, is going to become a function, right? And we can call it with one argument, okay? And only pass the argument at the end. So all throughout the program, okay, we did it in a point-free style, okay? And only at the end, at the call site, Okay, this is what this is. This is the call site, the actual place where the function is being called. So at the call site is the only point in the function or in our program over here that we're passing in the argument. Okay, up until this point, all we're doing is setup work. Okay, but for the setup work, there's no real computation being done at this point, right? It's like, say, hey, we're gonna pass you a function and then return us another function. But at this point, we don't really want to call it. All we're saying is we're just setting it up. Okay, whoever is gonna call this function, they'll pass in the value. Okay, but we don't want to pass in any values right now. All we're gonna say, hey, we want to create this function called is even, and what it is the opposite of is odd. And then once someone calls this even with the number, then that will be is odd. And then we can get into more advanced again, point free. I suggest, again, I'll pass around resources so you can go ahead and read more in depth, because there's certainly a lot that goes into this. But essentially, okay, it's exactly what we've talked about to this point, right? So because, okay, the function shape and because of the return, okay, and the way we're going to be composing functions, over here you can see that the output of mod2 passed in with that x becomes the input to equals 1 to this other function, okay? And again, if you've taken algebra or calculus, this should be like a review for you, because that's exactly what we're doing here, right? So all we're saying is, hey, let's say that mod2x, okay, equals, so all we're doing is mod 2x, does it equal, and then we're going to say 1, right? So we're saying, hey, it's odd. We're going to then separate it into two distinct functions. One does one thing, which is modular x, okay? And modular x, we can see that, again, it's just, x divided by y. So this one just divides, okay? And we created a general mod, so a general divide function that you pass in one argument, and then it becomes mod2, okay? Perfect. So mod2, pass in an argument, and then it'll divide the first argument by the second argument. And then we have another one called equal. And equal is just, hey, pass me one argument, and then I'll return you a function, and then you'll pass in another argument, and then I'm just going to compare them. Are they the same? And when we put these two functions together, right, we're saying, hey, we're going to pass around to the mod2 something else. Okay, we're going to pass around equals 1, right? And then we're going to pass mod2 to it. So, and then we're going to say is odd. And then we're going to pass a final argument. So we're passing in, in reality, we're going to be passing in one argument, two arguments, and then a third argument at the call set of is odd. But we can see that we have generalized, okay, each of these functions. And then instead of this division or this equal sign, okay, and instead of just focusing on the fact that we're in JavaScript, really we're creating these general functions that later on we're going to compose. And the output of one is going to become the input of the other, which is then going to become the output of the final call of the function, right? So that's how our functions can be composed together. And then if we wanted to, okay, since we've been kind of hinting at this for a little while now that we have all this, understanding of the function purity, the, putting them together with the shape, the arguments, and other things that do make up what a function is, okay? And that's what we needed to start at with functional programming. How is a function understood from the ground up? And that's why I wanted to go through all of this, so we have a complete understanding of what it is, what we're doing when we're creating functions, which is, again, it's not that complicated once you understand this, right? A function is just something that returns, given an input, it returns an output, okay? And it's something that is provable. So given the same inputs, it'll return the same outputs. And now what we do is, since we can pass functions around in functional programming, we're going to say, hey, we're going to create this general utility function called compose. And compose doesn't take two values, but it takes in two functions, okay? And it returns a third function, okay, that's going to be called at the call site later on. But at the beginning, all we're doing is we're just setting it up, okay? And what we're going to do eventually is, with that third argument being passed, once and only once that a third argument is passed, then we're going to say, hey, call the function 2, call it with function 1 passed in with that third argument, okay? And then the output of function 1 with that argument passed in, make it the input to the function 2. So this has to compute before this computes, okay? And then that third argument has to be provided, right? So over here, we can see, hey, we're going to say compose, okay? And then we're going to say, remember, look, I'm passing in the second function and then the first function, okay? So I'm calling them in reverse, okay? So we're going to be reading from right to left, okay? First, we're going to say mod2, then equals 1, and then is odd. So if once we call this function, okay, the first argument, okay, whatever is passed to is odd, okay, is going to become v, okay? Then v is going to be divided by 2, okay? And then is going to be computed, and it's going to be compared to equals 1, okay? And again, that looks a little convoluted right now, but that's why I wanted to make it as simple as possible, okay? So again, walk through it a few times if you need to, and go through the exercises in the class, okay? Because you know the only way to really understand this, besides the theory part, which is what we're going over now, is you have to get your hands a little bit dirty and really feel it out for yourself, okay? So I'm providing to you the examples and the exercises in the project file, okay? And then we'll create an app together, so you see all that being worked out. But you know what I want you to understand is you won't get a full understanding of this until you actually go ahead and do this for yourself. But now you have the theory, okay, behind how all this is going to be put together. And once we'll start building the app, it'll make more sense, okay? But we want to understand the theory of why, okay, and how is that functional programming works, so that you can see that it's not a lot of magic behind it, okay? It's just functions we're creating. That's all they are, okay? Sometimes we're setting up the functions, okay? Depending on how we pass in the arguments, or if we're passing in functions, we can compose functions. The outputs of some functions become the inputs of other functions, okay? And when we call them, since we can do the setup independently of the call sites, okay, we can set them up in one place and then call them in another place, right? So the server, or we can create APIs, okay, or libraries that we can use, and then on the display, remember, transportation, mutation, and then the display, right? So the transportation aspect, you know, it can be from server to client, okay? The mutation can be set up on the server, okay, then pass to the client, and then the client can do its own mutation depending on what its needs are, and then the client could display the information however it wants, okay? But the fact is that we're passing all these functions from server to client, and they don't really need to understand anything about each other than how they're going to be put together, okay? And then either the client or the server. So depending, if you want to pass, okay, that control over to the client side, then you can, right? Your functions, the server side code can be more general, and the client side code can be more specific, right? And that's where all the mutation can happen, while the server code is all pure functions, okay, and just composition. So you have a part where you're setting up your functions, you have a part where you're composing your functions, and then you're sending them to the client, and the client, depending on the needs of the client, then the client can specify how it wants to display the functions and do all that mutation, all the side effects at the call site, okay? But then we know that we can avoid a whole set of class issues, okay, that come with the inheritance model, that comes with binding our functions to models and things like that. We can decouple this, okay? And we can decouple each part of our program and put it together any way we want, right? So the compose function is a general function that we can use, you know, we can compose them any way we want, okay? We can pass to it any functions we want, and they'll be composed, okay? And that's exactly how we will eventually be writing our application. So that's what composition is. That's how we, you know, that's the importance of the arguments, the shape of the functions, and now we've dealt with the purity, you know, how it is that a function is composed, what it means to be a pure function. Now, then we have covered how to write the functions in order for them to be composed into larger applications. And now we're going to be actually starting to build these functions up into applications and working with them.